Ah, there it is, the red light. Red light always means, hey, start talking, man. It's time to go, go, go. Hey, welcome back. Hey, thank you for tuning us in. And hang on, I know there's a word on the screen that is very, I don't know, divisive is not the right word. Maybe it is, but certainly polarizing. Yeah, that probably is the right word. But hang on, as it says, let me explain. Okay, don't go yelling at the screen or throwing things or like saying no, 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 no. You're not gonna push that agenda onto me because it's not an agenda. Okay, just hang on. Let me set this up. But before we do that, hey, thank you for tuning this in. This is a rare one when well, I shouldn't say it like that, but it's just the bio people. So, hey, welcome. Thank you for making me a part of your educational journey. Love being a part of what you guys got going on and talking with you about where you're headed, whether you are a Crowder, whether you're a high school student. It's just a great time. So, hey, I've already kind of opened up the bag and let the cat poke its head out a little bit. So I'm going to let it jump out and just go ahead and talk about this. Hey, we are not, we are not going to push an agenda of things that really can't be proven, okay, that can't be discussed with a current examples. One of the things we are not going to do, and you can see it. Let me get a pen here. What's a good evolution color? Let's open it because we know gray wouldn't be. I don't know where I even had gray. I don't think I've ever selected, but maybe I must have. Let's go with this nice dark purple right here. I wonder what they call that. What is that? Oh, blue violet. All right, blue violet it is then. One of the things, let me click over here so it'll go away, is we are not going to do, and you can see them right here. Okay, when we set up our ground rules, okay, we are not going to try to go back in time and to conjecture all that stuff. Both sides of this argument, okay, whether you are on the religious side, whether you're on the science side, when they go to their extremes, okay, that's when the big wall gets put up and things start to break down as far as just talking about it. When scientists try to take the theory of evolution and then push it and then use it to go back in time to try to establish what might have happened. Okay, that's iffy ground right there. And when people in the religious side, which I would be in, okay, just to establish that, when they try to say, no, we're just gonna take the Bible and that's it. The problem with that is if you believe that we are created by God, okay, which I'd be one of those, but then you ignore the fact of what our cells do that God would have made, what the cells do from a hereditary standpoint and a DNA trait standpoint, then you kind of limit yourself to seeing the whole picture. And I do not mean that to be controversial or derogatory. Okay, but we are going to take a look at how cells create differences, okay, in species and how those species can change over time. Because you can see right here, okay, we are only going to talk about population change. Okay, if we can see it, we can work on figuring it out and that idea. But again, as it says right here, okay, populations evolve. Okay, not individuals. We're not talking about the three armed slug or things that are just abnormalities, or the whole idea of humans coming from chimps and that kind of stuff. Yeah, we're not going to do any of that. We're going to simply talk about how over time populations can change And with that change, you can generate either different species, or you can have a whole lot of variation within the same species. An example of what I'm saying there is the whole dog world. Okay, the reason why, okay, we'll say a German Shepherd and I don't know, a Labrador can reproduce and have puppies, okay, that are some kind of combination of the two, is because they're the same species. Okay, all those dogs, all those things are the same species. They're just different varieties of it. And if you use DNA, okay, and that's been a big game changer. I can't stress that enough. That the idea of being able to study and to map out genomes has been a game changer as far as recognizing who, classifying organisms and their proximity or their closeness in their DNA stuff. So, but through DNA research and work and learning, okay, we understand that all dog breeds, okay, or all the dog stuff that's out there, has kind of come from one general source, and that's the gray wolf. I mean, you can debate that, you can argue that, you can say no way, but that's fine. Okay, you certainly have that right. But if you again believe that we're all here because of God, again, which I would be one of those, but then you ignore the fact of what our cells can do in creating variation, then you just kind of limit yourself in what you can do. And that's kind of a closed-minded argument. And again, not to be derogatory or divisive, okay, but it is what it is. And that's the same thing that scientists can do when they say, no, there's no part of God in all this. It's all just simply what's happening. Both sides, when they disregard the obvious or the known, then you can't talk to a person like that. So again, we are not pushing an agenda. We are not going to talk about things that can't be analyzed and looked at. We're not going to try to extrapolate what we're going to talk about back to the beginning of time. No, I'm not doing any of that. We're simply going to talk about variations, okay, change, and the processes that bring about that change. And our number one process is simply going to be sexual selection. And again, I'm sorry you had to hear that word, but when you think about animals and the way in which they reproduce, humans, we kind of have this hallmark type mentality when it comes to reproduction. I mean, we've got this idea that there's somebody for everyone, and each individual has the opportunity to have a family and to pass on their legacy in that way, and that's fine. Okay, nothing wrong with that. It's not right or wrong. But when you think about other animals and other species, they don't have that mentality. They don't understand the Hallmark Channel and all that stuff. When you think about bullfrogs, okay, and how bullfrogs operated. Okay, those males, I mean, they have to fight for that right to be a part of the reproduction process. I mean, you think about a male bullfrog, okay, if he has to stake out a territory, okay, and that territory's got to have the resources that he needs to survive. So if you think about bullfrogs, they kind of come up to a pond, and they're looking for, some good protection from predators. They're looking for quick access to the water. So when something does come along, they hop into the water. We've all experienced that. I mean, as a 10-year-old boy, as myself, and as my son, and now we're getting to that grandson age. I mean, do you try to catch a bullfrog beside a pond? It's almost, it probably is impossible, unless you can trick it, maybe with a long net, perhaps. but it's the idea of staking out that territory. And he's also thinking about food resources. I mean, the grasshoppers and the insects and maybe even smaller frogs, slugs, whatever that are around there, are they plentiful? So he's got to worry about the food. He's got to worry about staking out that territory, and he's got to worry about other male bullfrogs coming along and saying, hey, you've got a pretty good gig right here. We're going to try to muscle in, and he's got to defend that territory. Okay? And if a bullfrog can accomplish all of that, okay, then what the females see is, hey, that guy's got it going on. Okay, so we're going to allow him to be the, I guess stock's probably the safest word to use there, and reproduce with him. And when that happens, okay, what that does, that ensures that the quality traits are passed along, and those smaller male bullfrogs, who either whether it's size or the ability to avoid predators, okay, they don't have that access to the females, then that just ensures that the quality traits is what's going to be passed on, and that's what we're going to focus on. Okay, that's what we were going to deal with. And if you think about, if only the quality traits are passed on to the next generation, then that's going to change that population. So if I take just that male bullfrog that has staked out that territory, if he lives longer, because maybe let's say he can jump farther, or he can jump quicker, maybe his hearing's a little bit better, so he can hear the predators coming from a further distance, and he can avoid those predators, then he's going to live longer and pass on those quality traits. And so let's just say, for example, and then I'll move on. Say you have a bullfrog, a male bullfrog, that maybe his toe pads or his length of his lower leg is just a little bit longer, okay, and so that allows him to jump faster, or maybe his muscles are a little bit bigger, which gives him a quicker twitch reflex to jump, and that allows him to avoid predators at a better rate than others. Then he's going to survive long, and he's going to pass on those traits. And so what, in turn, the way this change happens is what is once rare in that bullfrog, maybe he's got the longest set of legs or the biggest set of muscles, okay, through a mutation or just heredity. His parents, they just passed the right genes along that enabled him to have that. Okay, so it's in one frog right now. But over time, if he's the parental stock for the next generation, then a larger majority of bullfrogs in the future are going to have that trait. And that's how the change occurs. So, and that's the things that we're going to focus on, things that we can actually see, things that we can actually describe, things that we can actually talk about, because they're current examples. Okay. So I said all that, and hopefully that calms all the fears and processes. So with that, we're going to kind of just get started. Oh, I didn't even really do my good intro. Hey, I got the water here. It's pre-lunch. Well, actually, as you can see on the clock, it's after 12:30. We're kind of getting a late start. We did some stuff this morning. Kind of have a late start here. But I got my water, got my notes here. Okay, so I know it already seems like we've kind of gotten started since we are already 14 minutes in. But now we'll get started. But again, hey, in class, if you want to talk about this, you want to just speak your piece, hey, that's fine. Because if we can't discuss it, okay, then we probably shouldn't even be talking about it. So you just, if you want something you want to say, or you want to talk about, or you want to debate a particular thing, that's fine. Just hey, let me know, and we can talk about it as long as you want. So if we think about these other things I've got written down here. And you know me, I typically don't like to have a bunch of stuff already pre-typed and just read it to you, because I mean that's boring. That's not a strong teacher move right there. Sorry, Miss Hankins, but that's not a strong teacher move. But we want to. I just want to kind of give you a chance to see it right off the bat and to recognize that kind of stuff. So let's just talk about some more of this. Let's go right here. Heredity. Okay, that is kind of the focal point of all that we're going to be talking about. Because if you think about my example of the bullfrogs, that's how the rest of the animal kingdom operates. Okay, not everybody has a chance to reproduce. Only the best do. Okay, and you can think about, and I got a little thing over here about our deer. Okay, deer the same way. Okay, and I got bullfrogs there, and you think about cardinals. Okay, cardinals, that bright red male. Okay, that's what the females are looking for, because if he's got that bright red, that means he's healthy. Okay, that means he comes from a good stock. Okay, and the females are going to choose him to provide the genetic material for their offspring. And if they do that, again, that pushes the quality traits into the next generation. And so again, what might be rare today is common tomorrow. And that's the change we're talking about. Okay, that's the evolutionary change we're talking about. Just populations. Okay, I can't say it enough. We're talking about populations. Okay, not individuals. Where do I have that? Oh yeah, I have that right here. Not individuals. Okay, we're not talking about this particular slug developing an arm and that kind of stuff. No, not doing that. And I've already mentioned this a couple of times. So let me put an arrow right there. Okay, and it's not just the fact that the quality traits are pressed forward, it's just the lesser traits are ignored, okay, to some extent. And of course, these processes change populations over time. Okay, and we're not talking a weekend, we're not talking a year, okay, we're talking a substantial amount of time it takes to get this done. And whether that's a decade, or that's 100 years, that's another variation or a variable, or a variable to this whole process. But it's headed in that direction. So if you think about, you know who else? I mentioned dog breeds, but you know who else practices this process? Okay, breeders. Okay, we're at this house. I mean, not me, but we're a dachshund family. But if you think about dog breeds, okay, what's the driving force behind parent selection? Quality traits. I mean, if you think about the AKC, and around here we watch the dog shows and we like the different breeds and seeing that kind of stuff, man, they're pressing those quality traits. Whatever the breed is, whatever the desirable traits are, or what they're looking for to say, hey, that is a Labrador, that's a German Shepherd. That's what the breeders are pressing for. And if they get a male that's got those traits, okay, if they're in the breeding business and they've got a male that has those traits, that's the male that they use. Okay, if they get a puppy that, say, is a male, but it doesn't have the right kind of hair texture, or the right coloration, or just, maybe it's the shape of the jaw, whatever it may be, okay, then that puppy is, it doesn't become part of the genetic material for moving forward, and as far as the business side of it is. So they practice that. Think about, cattle. Okay, if you're a cattle rancher and it's time to buy a new bull, okay, you don't go out and just get any bull. You just don't go out and say, hey, got a bull? All right, I'll take it. No, they don't do that. Look them over. Hey, if it's got If it's a small, weak male bull, nobody's going to buy that. No, what are they looking for? Quality traits. Okay, and when they buy that bull with the quality traits, it's because they want those traits passed on to the future generations. So that's the idea what we're talking about. Quality traits, desirable traits, selecting for particular traits, and whether it's artificial, as in breeders, like, okay, they yes, yes, yes for those males and females, but no for those. Whether it's artificial like that or just natural selection, and yeah, we're going to talk about that as well, as in the animal kingdom, in the real world. That's how change happens over time. You know, our own deer population, same thing, sexual selection. I'm sorry you had to hear that. But the big bucks are the ones who get to be part of the reproduction process. The smaller ones don't, because the females, okay, they allow it. They choose that based on what instinctively they're looking for. So if only the best reproduce, okay, and it's also on the female side. So if the best females and the best males are reproducing, then that's going to mean that those quality traits are what's pressed on. So I went about 20 minutes saying the same thing in a million different ways. But again, just wanted to reassure you that, as it says down here, okay, that we're only going to work within the known facts. Okay, we're going to avoid conjecture. We're going to talk about the things that are true, with the purpose of explaining the things that are currently happening. Okay, so with that, again, we'll get started 20 minutes in. But anyway, hey, again, just be assured we're taking care of your beliefs. We're not trying to push anything on here that can't be discussed with current and real examples. Okay, so let's bring up our next idea here, and this is kind of small. Let me see if I can't make this a little bit bigger. And again, I don't like to have pre-typed stuff, but again, just emphasizing what we're going to be doing here. And the idea with Darwin, and again, that word brings up all kinds of feelings on both sides. But again, we're not going to focus on the conjecture side of what people do with his theories. Oh, I didn't even mention, got my Royals gear on today, not because particularly the Royals, but we're heavy baseball mode right now. It's World Series time, and enjoying that. Love me some baseball. Man, I love baseball, and care what team. I love watching the players and the actions, and because it's such a one-on-one, and it's such a difficult sport that when somebody achieves defensively, offensively, it's just amazing to watch. And grew up playing baseball. I just love it. And so it's World Series time, which I'm enjoying. Been great for the first 3 games. Number 4 is tonight, so enjoyed that. Anyway, that's why the Royals gear is on today. Plus, I needed some sleep. It's just a little cool, man. We went from 85 on Wednesday to by Friday morning, we're like, man, where's the Parkers at? What's going on here? And with the rainy stuff. But anyway, love me some fall. And all right. But Darwin. Okay, so here's some things that we can't ignore. Okay, and again, that's what we want to focus on, the things that we can actually see and point at. And here's, let me get my blue violet back up and going again here. So if we think about this stuff here, okay, the things I shouldn't say two, but some of the things that drove his research was the fact that he arrived on these islands, and as he went from island to island, he noticed, especially with the tortoises and the finches, those were 2 of his big specimens. Excuse me, my nose is itching there. And I want to do that off camera, which is a strong teacher move right there. But he noticed that the tortoise shells could be used to classify what island they came from or their habitat. And because the different habitats kind of push quality traits into a certain direction, meaning where you had to travel to or how you were going to get the food sources and things. And the same with the finches. Some islands have big seeds, some islands had small seeds, some islands had in between, some were long and thin, others were short and kind of fat or wide. And so just that variation, he noticed that the beaks of the different finches, okay, the finches were all the same, okay, the same type, same species, but their beaks were different. And the question is, why? Well, that's what we're about to explore, or have been exploring now for 25 minutes. And wait for it, wait for it, wait for it, 40 seconds. And when we talk about, I just have to do it here. You can see here, different, these are all the same tortoises, but, okay, between long necks, rounded, domed, more flat, okay, different deals from the different islands, as you can see here, because the habitats were different. So what that meant is that turtles that had a certain kind of shell, okay, they were more successful in getting resources. And if you're more successful in getting resources, you're going to live longer. If you're going to live longer, you're going to reproduce more than turtles that can't. And that's the essence of natural selection, which we'll talk about. Same thing with the finches down here. Okay, all the same types, okay, but evolved over time with different beaks. Okay, and again, it pointed to different food resources. And then once you establish that difference, the food resources, the seeds, okay, then through change, mutations, whatever, advantageous traits, you can kind of change different aspects of the birds as well. Just like, again, talking about our own Missouri deer population. Okay, you can't deny the fact that over time the deers have gotten bigger. Okay, if I've got only the biggest male deer being part of the reproduction process, that's going to make the overall average deer bigger, again, in time. Okay, over a couple hundred years of data collection. All right, so let me close this out, and we're going to go all the way up here. Don't look at those pictures; those are for later, because there's some things that we have to establish. It's kind of background information, and the first one is, move this all the way up here, is when we talk about traits. What are we talking about? Okay, when we say traits. Okay, so we got things maybe like size. Okay, if you think about height in adults, if you think about length of maybe snakes, muscular size of lions, size is a genetic trait. Okay, that the genes on the DNA are going to decide, okay, for that offspring what they have. And if you have, let's say, the lion kingdom, and the lions are a great example of what we're talking about, because if you think about how lions operate, it's little packs. Okay, and so you've got the one lead adult male, and then a series of 3 to 5 to 7 females, and then of course they're cubs. And then over time, it can obviously as reproduction occurs and get new lions, it just kind of grows. But then there's some factors that reduce it as well. Death would be one of those. The idea of any male that is born at some point in time is going to do one or two things. It's either going to leave to go establish its own little pack, or it's going to challenge for the lead. And if it is successful, it now is part in charge, and obviously probably the current adult male was either killed or it had to leave. And so if you have, based on percentages, if you have 5 reproducing female lions and they give you 2 to 3 each year, and half of those are males, then you got a big selection of them that are just going to be leaving over time. But anyway, and of course there's the whole, I don't know, there's not too many lion predators out there in Africa, but you know, there could be some. Hunters could be a possible one. But it's the idea of size. Okay, it could be speed. Again, which would be a combination of, and it can be flight speed, it can be running speed. If you're a rabbit, or if you're a bird, butterfly, whatever. And of course, speed would be a combination of genes working together. The muscles associated with the flight pattern or the flying process, the size of the wings, the thickness, you know, the body weight of the organism. You could have huge wings, but if you're 200 pounds, okay, you're not going to get off the ground very quick. So all that, and so again, multiple genes working together there. And I mentioned this earlier with the bullfrogs, but even something like hearing and alertness. Okay, if you're an animal that's got better, just for some reason, through heredity and the passing of traits, your hearing's a little bit better, so you can hear the predators from a further distance. Okay, and are alert to that and get on the move. It's the classic joke. You know, two hunters are out there and they come upon a grizzly bear, and the one hunter says, "I don't have to outrun the grizzly bear. I just got to outrun you." So it's kind of that idea of predators. If a predator shows up and there's 3 rabbits in the field, and one of them or even 2 of them hear the predator earlier and take off, and the third one doesn't, well, guess which one the predator's probably going to catch or may catch? That third one. So if he has reduced traits, we just eliminated those traits, and that's all part of the big picture process of change over time. And so when we're talking about traits, that's what we're talking about. So we want to establish that, and then the next thing we want to establish is when we say population, what are we talking about? So let me get a little box here so we can officially put this up there. When we say populations, what are we talking about? Well, we're talking about, and there's my first strong teacher move as far as outline format. We're talking about group of the same individuals. I know individuals is kind of a, oh, that don't look right at all. Oh. Should have been a D there. Yeah, there we go. Should have been a D there instead of a D. Individual is kind of a human term, but we're talking about in an area. Let me just finish my thought here. In the same area. So if we're thinking about a grassy field, okay, all the rabbits, okay, that are the same species, that's what you mean by population. If you think grasshoppers, okay, all the grasshoppers that are the same species in that same area, that's what we mean by population. Okay, so we will close that out. And 1, 2, all right, so our next topic, let me get a little box here, is kind of the umbrella term for all of the things that we are talking about. And to break down this word, the word natural is used because it happens automatically, or it happens within the processes that are established by the organisms in the real world. Okay, it naturally occurs is the reason why that word is chosen, as opposed to artificial selection, which is what breeders do. Okay, they look at individuals and say, yes, we can use you. No, we're not going to use you because you don't have the right traits that we're looking for. That would be artificial. Okay, when it comes to natural selection, and there's my outlined format, we got 2 things going on that we have to recognize and talk about. In other words, the struggle for resources is real. I mean, the rabbit, I shouldn't say the rabbit, let's go with the predator. The hawk out there, okay, he's not going to Walmart's or Woods or Muncie's, is the grocery store here, okay, and getting the clicking on the app and having somebody get all the food resources and going and just paying for it. No, that hawk has to hunt, has to find, has to detect. And because of that, if it has the quality traits to do that successfully, okay, it's going to live longer, which in turn means it'll reproduce more and pass on those quality traits. And again, we just can't say that enough. That's what we're focused on, the ability to have those quality traits and to help get the resources that you need to survive, because they got to do it all. I mean, if you think about a rabbit, okay, now rabbits are, their resources are pretty abundant, okay, plant material, grassy fields, whatever, but they got to, while they're eating, okay, they got to be thinking about those predators and when they can show up. And for a rabbit, I mean, it can be anywhere from a hawk to a coyote, a wolf, a dog, whatever. So the struggle for them is real, okay, and it's every day, okay, and they've got to have those traits to help out. The second part of it is, okay, outline format, and it's the idea of survival of the fittest. And there's no way that's right. There we go, survival. And that may not even be right. What do I got here? SURVIVA, yeah, there we go. Survival of the fittest. Okay, and again, we've said this in a bunch of ways, or a bunch of times in different ways, but that's what we're talking about. Okay, if I, as an organism, have the traits that enable me to survive longer, I'm going to reproduce more and pass those quality traits on to the next generation. And again, so if I have a trait and I'm the only one through heredity, mutation, whatever, okay, and I start passing that trait on, that is going to ensure that future generations, a majority of them, have that quality trait, whatever the trait may be. Hearing, vision, muscle, size, speed, alertness, whatever it is. Okay, it's going to ensure that gets passed on. And let me go ahead and I'm just going to type this so you'll put it in your notes officially. It's all about survival. This is fun, me just not talking and typing only. If an organism has quality traits, and survives longer, then it will reproduce more, future generations. And then one more. This means that the trait that is rare today, common tomorrow. And again, I've said it a couple times, but just what I mean by that is the fact that if I'm a let's pick something. Well, we'll go with the cardinal. Okay, if I've got the brightest red plumage, feather coloration in an area, I've got the brightest. I'm a cardinal. I'm the brightest red cardinal in the field, and the females are looking for that. Okay, so say I've got the brightest. Say there's, I don't know, 15 females, okay, in a particular area, and they're looking at me like, okay, that's the brightest coloration, and in their mind that means he's healthy, he's vibrant, he's going to provide good genetic stock, and so say of the 15, that particular cardinal is allowed to reproduce with, we'll say, 10 of them. Okay, so those 10 are going to produce offspring, okay, using that quality trait, and so each of those new cardinals will have the opportunity, heredity-wise, of getting that new trait. So it goes from being rare today, one cardinal has it, to the possibility, and again, heredity is a percentage anomaly. Okay, it doesn't mean that they'll all have it. It means there's a possibility that they'll all have it. If the dominant traits are passed successfully, then now we go from a possibility of one having it to possibly, if a cardinal produces, we'll say 3 eggs, and 60% get the trait, 3 eggs times 10, that's 30. 60% of that is 18. So now it goes from one having it to a possibility of 19 birds having it. Okay, and then those birds go through the reproduction process, and it just grows exponentially through the ranks over time. And that's the process of change that we're talking about. Populations over time selecting for traits naturally based on their quality and based on their processes that they go through. Okay, and that's what we are referring to when we say evolution. That's what we're talking about. All right, so that's natural selection. Yeah, no, I wanted to say a couple more things here. I look down there. So again, we've said these, but just so you'll have them in your notes. That what drives natural selection. Let's go with a number here. Parents. Parents pass on traits. Oh, not traits. No, we don't want that. There we go. Traits. And then 2. Offsprings vary from each other. And so again, when we say that, again, we're talking heredities, we're talking those Punnett squares, and hopefully that you've got some experience with, to whether it's the dominant trait, the recessive trait, whether the parents are homozygous dominant, homozygous recessive, heterozygous, all that stuff comes into play that produces that variation. Okay, a little drink here. Oh, I also forgot to mention that we're just going to do one video for this chapter. And so we're going to power through. As you can see, we're at 44 minutes. So we're just going to power through. So it may be a little bit longer than what I typically like to throw out there. But there is just going to be one. And so there isn't enough material to do 2 50s or 2 45s. So we're just going to do one here and move on. All right, now, next topic. Let me slide this up here, and I'm going to have to, let me go all the way up because I got to move all this stuff down because we're getting there. I had to kind of guess where to put the pictures, and now we got to just move them down because I need more room for earlier topics. And there's my previous one. So let's put a box right. No, that didn't work. Put a box right there. And our topic here is adaptation. Okay, adaptation is the word that when we talk about these quality traits, okay, that enables an offspring to survive, because it's based on habitat is a lot of it. Okay, resources is a lot of it. But let me define that. Adaptation. Nope, I need my quality. Strong teacher move there. Back up here. Nope. There we go. Organism to survive and then reproduce more often. Okay, so that's the idea of what we're talking about. So any adaptation that a particular organism might have through heredity, okay, and so again, we go back to the examples we've talked a bunch about. It could be size, strength, speed, whatever it may be. Okay, if it allows the organism to live longer, okay, then they'll reproduce more. And this is based on habitat. Okay, and when we say habitat, an easy oversimplification example would simply be like a grasshopper. Okay, if you think about a grasshopper in a grassy field, the green ones, the yellowish ones, the brown ones, they blend in pretty good to their surroundings. But and like an albino organism would fit into this. But if you took a pink grasshopper, okay, and threw a bunch of them out there in the grassy field, they're going to get picked off pretty quick by the birds because they're going to stand out. And I know that's an over-exaggerated example, but that's what we're talking about. If you've got a trait that allows you to blend in to the habitat or to survive in the habitat, whatever the trait may be, okay, that's going to allow you to live longer, reproduce more, passing on that quality trait to future generations. Okay, also, based on resources. Okay, are you able to gather the resources that you need? And the big one will obviously be food and water. Okay, but from a food standpoint, if you're a predator and if you're a slow coyote, okay, you don't sense prey before the others do, and you're slower than they are, man, you're not going to live long. Okay, and when you're gone, so are those lesser traits. Okay, and that's again the focal point of what we're talking about in the change we're talking about. The lesser traits are removed or ignored, and the quality traits are selected for and chosen. Okay, our next topic, and we got flipping over here, 4 more topics, and we're done. So we're probably going to be right at that 75-minute mark. So adaptation. So now, but most of these are pretty short, so we'll see how long actually it goes here. Move this over here. Evidence. And even if, and no pun intended, but even the evolution of the evidence is pretty fascinating work. And again, for me, all this stuff, some of it is, as we mentioned earlier, divisive, and I don't have to explain you how that is. Just the word evolution alone just puts walls up And we just had a freeze there, and hopefully the video was still tuned up with the lips moving and the words that you're hearing, but sometimes that is not the case. I really need to I guess I need to upgrade my computer so that doesn't happen, because that seems to happen almost every video now. So I guess we're going to be in the market this Christmas break for a new computer, but we'll see. Evidence. It used to be fossil records, or we're just comparing. If we keep it, if we keep our examples in the current mindset, body structure today to what we saw, evidence 100 years ago. But the fossil record, the changes in organisms based on what was to what is current, used to be driven heavily by the fossil records, but now there's a new player, and we mentioned DNA. DNA has been a game changer. Okay, the same process that we can use to determine parental or parent evaluation, the old, determining who the dad is kind of a thing. We can also use to look at common ancestors, and are they from the same line, from the same line's the best word. I can't think of a better word than that. And that's how we know that all the dog breeds come from the gray wolves, which you can see just slightly above the gray wolf's head above my picture there. It's DNA. Being able to do that and to establish who's more closely related to who has been a pretty big deal. And most work anymore is DNA driven. If you're a research biologist of whatever field, you've got to have a pretty decent understanding of the DNA line of your organism of choice. Okay. Another interesting aspect, and I like talking about this, and you know me well enough by now to know that the things that I enjoy in science are the cool factors, the impressive things that our cells can do. And this one kind of falls into that place, but it's the idea of convergent evolution. And this is, let me define that, different organisms developing the same structure, because it is advantageous I think that's right. It's advantageous, but it is formed differently, and that doesn't sound like it is what I'm saying, but I'll show you pictures, and they're right down there below there if you want to already start looking at them while I finish this up. Well, that definitely doesn't look right. Yeah, I think I got it that time. But it's formed differently. And what I mean by that is we're going to bring this up here. I'm just going to put it up here above. Okay, think about wings. Okay, I got a bat wing. I got a eastern bluebird. That's our state bird, as you know. And then we got a fly. Okay, they all have wings. Okay, so wings are advantageous to avoiding predators. Okay, that we can't deny. And excuse me just for a second. The room is getting a little cool. I'm in my office here, our little man cave, kind of a deal. It's on the north side of the house, and so it gets a little cooler than the rest of the house. And that's probably why she let me have this one, because she knew she didn't want that room. But anyway, that's a whole different topic for a whole another day. But it's the idea of these structures are advantageous Okay, the bat, it's more about catching prey. The bluebird, getting to resources, avoiding predators. The fly, again, getting to resources, avoiding predators. But they're structured entirely different. So it's like different species. And I'm going to say the phrase got the same idea. Again, that's not the evolution we're talking about. The organisms do not say, hey, you know what would be cool? You know what would be helpful? Wings. All right, so let's go. Wings. No, it don't work that way. It's got to be DNA driven, that kind of stuff. But they each have them. Okay, they're structured differently, but they're advantageous. And just the cool fact that they arrived kind of at that point in time. That's just, to me, it's interesting to talk about and to mention. And let's see. Oh, got an arrow there right at the button there. Yeah, that's my other features I have, but I don't hardly use. I did have to use them once for. Well, you guys saw my photosynthesis when I had to use that pen, but so that's the idea of that. So let's get a new text box here, and now I don't want to go away. Don't want to pause that. Oh, there it goes. I was going to say, I don't want to click on anything because it'll mess something up. And but another aspect of all this, where am I? Oh, it's time to flip over here. We're on the back side, so now we're down to two topics. It's this idea of different species. And I lost my text box there, but that's all right. Oh, wait, I'm not done here with convergent stuff. And this is the part that I find fascinating. And let me move this down below that type in case you were still trying to write. But you can see here, these are all, again, arms, if you want to express it that way. But these are kind of the same appendages, but again, kind of structured a little bit differently, again, based on what is advantageous in the particular organism's world, habitat. Okay, you can see the human, and these bones are color-coded, so you can see that the same bone is there in each of the different organisms, human, dog, bird, and a whale, but they're slightly different. Okay, you can see the ulna and radius here of a human, dog, and a bird. It's kind of similar, but then when you go to a whale, it's really reduced. Whales just have the flippers kind of thing, whereas the other organisms have to stand on theirs and I didn't mean stand. Use theirs as arms and stuff. So the bones are a little bit longer. This obviously would be the flapper here, or the flipper. This would be a wing here, and this would be the dog's front, what we'd call leg, which really isn't a leg, it's actually an arm. And of course, this is a human arm here. And that whole process of, again, same structure, a little bit different function. So therefore, over time, it's kind of changed the way it looks and the way it's used. Okay, our next topic, and again, we got two left, so we're setting at 58. So 75 minutes is looking real positive now. Species. Okay, all of this stuff we're talking about is the idea of different species. Okay, and we're going to go through an example of how over time a species can kind of change, go from one to two, and sometimes we cause that artificially or indirectly is probably a better word, but then there's some other natural things as well. Okay, so when we're talking species, we're talking group of organisms that can reproduce. And when we say can reproduce, we're not only talking a production of offspring, but we're also talking mechanics as well. and that's about as far as into that as I'm gonna go. There's a reason why elephants and guinea pigs don't produce offspring. One, there's just not a good match, and I'll just leave that at that. Structurally, it's just not a good match. It ain't gonna happen. Flies and snakes don't produce offspring, and there's some obvious reasons why. It just the parts aren't going to line up, and we'll leave it at that. But it's a species, group of organisms that can reproduce. I'm going to type the word physically, and again, we'll just leave it at that. That's too many Y's there. Oh, not enough C's though. No, that ain't right either. No, I think that's right. Physically and the offspring. We'll use the word viable. That simply means that they're fertile. They're able to reproduce as well. So a group of organisms that can reproduce physically and the offsprings are viable. That's a species. So a horse and a donkey, okay, they can do the first part. They can reproduce physically, and they produce an offspring, okay, the mule. But guess what the mules are? The mules are sterile, okay. They can't go on and reproduce. And also, even though that offspring is useful, because mules are strong, they get the strength of a horse, the smaller size of the donkey, and they're just great work animals, as you know. I don't have to tell you that. But they can't, two mules can't reproduce. So horses and donkeys are not the same species, okay. A lot of similarities, okay. And at one time you could debate, or you could look at or study or research, were they the same species, and over time separated off for whatever, for a lot of variety of reasons. You could research that, and the evidence would just the physical visual evidence would lean you towards a theory that, or a hypothesis, that they were at one time the same, but that's something a person just had to research to know. But for a species, we're talking about a group of organisms that can reproduce physically, and the offsprings are viable. And okay, and so some examples we're talking about. Obviously, we've talked a lot about dogs. Okay, any breed of dog can reproduce with any other breed of dog, as far as the offspring are fertile. Okay, so you can get all your labradoodles, you can get all your all those different combinations. Like for example, our Avery here, our pit bull, greyhound, lab, and you can physically see all the different traits. You can see the pit bull head. I mean, if you look at her face, if all you saw was her head, if I just showed you a picture of her face, you're gonna say, "Oh, you got your pit bull, nice." No, the eyes and the skull. I mean, that's pit bull. And as I always joke, the problem with having the pit bull head is that controls the rest of the body. So she's gentle, but man, if she's got that pit bull focus, that if she wants something, if she needs something, she decides that she wants to have something, yeah, it's on, and it drives the rest of the mental body. But she got the lab body and tail, and then she got the greyhound legs, Great Dane legs. I'm sorry, not greyhound. Great Dane legs, which are long and thin. So you got a big husky body on thin, long legs, and that just hasn't worked. She's got some leg issues. It's actually just one. Her back left is there's just something going on there that she'll just be playing around, and it'll hurt. So she's got to stop. She sometimes gives a little yelp, and you can tell when she's hurting because she just stops playing and goes and lays down. And she's got some supplement stuff that she takes to help with that, and it does help her. But it's just structurally she don't have the right legs. But all those breeds are in there, and that just points to the fact of what I'm talking about. All dogs are the same species. Okay, there's just a lot of variations, and that's what we're talking about here. Other examples, as I mentioned, I've already went to this example, but not there. But the horse and donkey, similar, okay, but not the same species because they can't reproduce fertile offspring. And then I already mentioned, a crazy example like a lizard. Okay, lizard and frogs aren't going to make offspring. Just too different. It's just not going to happen. So that's what we're talking about, species, and so we're just going to give an example of. And let me move. I'll just move this. You can still see everything. Close that, and we'll slide up here a little bit. And I'm just going to come all the way down here because that's where my pictures are. And this will be our last topic here. So we've mentioned that change happens over time, naturally, natural selection, because of trait selection, and a lot of it is sexual selection. It could also be the resources that you are surrounded by. The advantageous trait is a certain one, and therefore that organism can access the resources better, easier, so they live longer than organisms of the same type that cannot. And we've mentioned that habitat, survival, again, drives choice of traits that make it advantageous for that. And so our last thing we're going to talk about is perhaps providing another example of how things can change over time. And our topic here is speciation. And this is the kind of stuff that Darwin kind of experienced and examined, because he could see it, because he was able to pull back and see all the picture and not just try to look at one and try to figure out what was going on. He could, as he traveled from island to island, he could see these variations of the same thing. And where are we at? Oh, speciation. Okay, let's start with a definition. Change over time that separates I don't use the word large. Separates one group into two or more groups. And let me I'll move these. And come back to this, edit. Okay, and this occurs because something big happens. And it can be a natural disaster kind of thing, or us. Okay, or mankind did something. That's what my example is going to be, a way in which maybe we can cause speciation. Okay, so, and when I say something big, maybe it's a volcanic eruption, maybe it's a drought, and resources change. Maybe it's a mudslide, earthquake, lack of rain, extra rain, and resources change. It changes the habitat, and therefore maybe now a different trait is the advantageous trait. But let's go through a little story here, and I'm just going to close this out. And you may use a variety of pins now. So say I've got this big, and I'm going to use this entire area over here. I got this big field. Okay, this is a big field, and in this field, there's a grassy field. There's a bunch of grasshoppers. Okay, a bunch of grasshoppers. Let me think through this before I go too much farther. Yeah, grasshoppers. Okay, so that's our organisms, and we're going to focus on two particular grasshoppers. Carl, the grasshopper. Carl is a good green grasshopper. That's his big trait. He blends in very successfully, okay, with the grass. Okay, that's his advantageous trait. The other one is Gary the grasshopper. Okay, Gary the grasshopper. Now, Gary isn't so much green, he's more of a brownish. It's a great S, but he's big. He's strong. He can jump the furthest of any grasshopper. Put the word jump here. Okay. So these are our two grasshoppers that we're gonna focus on. Okay. So for our story, then what happens? Humans, we decide, hey, we need a road through here. Okay, we need a road through here, whether it's a highway, just a regular road, 2-lane road, whatever. But for some reason, we decide that we're going to put, where's that gray? Oh, you know what? Where's that gray at? I could use that gray right here. Yeah. Silver. Which one's a better road? Light gray? Nah, we want dark. We want dark gray. All right. So we're going to put a road through here. And let me get the eraser and erase this green in here. And up here. Put this green in here. So now we've built a road. Okay, and so when all this equipment started showing up and people started working out here, these grasshoppers had to scurry and go either, let me come back to my green here, either this direction and this direction. All right. Our next thing that we're going to introduce to our story is the blue. Okay, and because there's the main water area for this, okay, is right here. Okay, this water was kind of what helped keep everything nice and green. Okay, along with the rain and the morning dew and stuff, but it's over here. Okay, so maybe you can kind of see where I'm going with this. So over time, that changes the plants. Okay, over time, since this area is a little drier, okay, not much drier, but a little drier than this area over here stays nice and green. So let's bring the green back. Nice and green over here, but over here, do I got a? we'll go with this. We're going to put just a little bit of, just that represents, but then we'll also put some green in there as well. Okay, just a little bit drier. So I did that color just to let you know that, hey, maybe the plants changed a little bit, and no longer are we thick in grass, but a few of the plants now are things that can handle a little more drier environment. Okay, so because we built this highway, we established a little bit of change in the habitat, and over time the habitat changed. And so even the rain, when it rains real heavy, you know, if this was it kind of all if this is the lower part and this is that part, we can maybe run this way and whatever, and maybe we just changed the habitat to where now the water kind of runs this way, but we just changed the habitat. Now we go back to our grasshoppers. Carl, when the time came to flee, okay, Carl went to this side, and again, that's going to be just a random act. And let's say Gary, where's that brown at? Is that what I got there yet? No, I don't mean to be. Gary came over here, and now our story is set. Okay, so Gary is a little bit more brownish. Gary, or Carl, is more greenish. Carl is going to flourish over here in this green, and Gary is going to flourish in this brown. Okay, and plus Gary is big and jumps well. So over time, if Gary is the best male grasshopper on this side, and Carl is the best male grasshopper on this side, okay, over time what's going to happen is most of these grasshoppers over here are going to be green. It used to be some green and some brown, but now because Carl is supplying the male reproductive stock, we're going to go towards more of a green. And over here, since Gary is the main male stock, we're going to slide away from the green and become more brown, plus to be the big jumpers as well. So hopefully you can kind of see that from that description and that story. And if we fast forward 100 years, what we possibly could see is the fact that most of these grasshoppers are green and most of these are brown. Okay, and if that change extrapolates out even more to where the reproductive aspect occurs and that changes as well, you could get to the point to where these eventually, okay, and again we're saying possibly could become two separate species, to where even if they came back together over time, they would be different enough where they couldn't reproduce. And so that's the idea with speciation. But again, we're talking lots of time. We're talking something happened to separate the groups, and then they kind of evolved away from each other again over time. And it's all about the reproduction. Okay, not that one grasshopper became a frog and the other grasshopper did something else. No, all grasshoppers. Okay, but enough change occurred over a long period of time to where maybe they're no longer the same, and that's one way that speciation kind of works. And the other example, and we'll go back to let's go back to our purple here, our blue violet. This is kind of some stuff that Darwin saw. You know, maybe you've got this land area, and then maybe a mountain range formed, and then the land is separated. This is kind of what my example is here. And then you go from enough change happens on one side where now you have two separate species. But more what Darwin saw is over here, and this is our last thing before shutting her down. And man, we're almost at 80 minutes. Whew, sorry about that. The idea of you got the mainland, you got an island. I mean, let me start down here. You got the mainland, island. Some organisms get out there somehow, and then over time change enough to become different from each other. So that's just an idea, an explanation of how it's possible to happen. That's the idea of speciation. So hey, thanks for hanging in there with me. Thanks for listening. Hopefully we're able to kind of explain some expressions of evolution and talk about populations and how they can change and so on and so forth. But again, if you want to talk more about it, let me know. We can certainly do that. And hey, with that, we will say goodbye until next time.